Hi everyone, hope you're having a great time at TestMu Conf. Welcome to this session on backward scoring, ranking test suites. What a cool name for this session, right? I am Himanshu, Director Demand Generation at TestMu AI, and I'll be your host. I have a quick request for all of you before we start. Please share your learnings on LinkedIn and X. You can use the hashtag TestMuConf so the rest of the community can follow along. Now, moving on to today's session, test coverage is a metric which everyone has, but nobody fully trusts it. Even a 90% covered code base can ship the incidents. So, the real question on the table is how many of tests have ever caught a real incident? And to help us answer that, I have with me Parth Sarthi Samal, Quality Engineering Manager at Paramount. Parth has over 21 years of experience in software testing and he leads the test teams for streaming platforms serving millions of viewers. His work spans test automation, performance engineering, and integrating QA into DevOps pipelines. Parth, welcome to TestMuCon 2026. This stage is all yours.
Thank you, Himanshu, for the warm introduction. Good morning, good evening, and wherever you're watching from. Like every QA organization I've worked with tracks code coverage. Almost none of them track whether a test has ever caught anything real. So those are different questions, right? And today I want to show you a method of answering the second one. By the end of this session, every test in your suite gets one of the three verdicts, as you can see here: proven, duplicate, or unproven. Keep those three words in your head. So we are going to go back to and fro through these three words. Now, about me, I think Himanshu did a brief about me. I'm working as a quality engineering manager at Paramount. I have 22 plus years in quality engineering. I've led cross platform teams serving millions of customers across industries and geographies throughout all these 2 decades. I focus primarily on test automation, performance engineering, DevOps integration, DevSecOps, AI assisted test scaling, AI assisted development, and other products as well. So you can connect with me at LinkedIn and I'll be happy to connect with you. So, what will we cover in this session? So, as you can see here, this is basically a quick map for you to navigate. There are 6 stops in this, and we have the problem, like why 90% coverage still ships incidents, the method, replaying real incidents against every candidate test, the results, what this 4,200 tests actually proved in 3 verdicts, as we discussed earlier, the limits where the score gets reactive and preventive tests wrong. So the practice which flags for the owner review instead of auto deleting, and the key takeaways, like the 5 things for you to do in your own test suite so that you don't go through these issues. So let's get started. So this is the real number from a case study, like roughly 4,200 odd test cases replayed against every logged incident in that window. So as you can see here, 80% came back proven, 8% duplicate, and 12% uh, unproven, right? So one test in 8 never failed on a single real incident the entire time, as you can see here. So the last number is the one everyone in this room is already forming an opinion about. Hold that opinion loosely, I would say. By the end of this talk, it's going to get more complicated than it actually sounds right now. So, why coverage isn't enough? So, here's the problem basically in miniature form. Before we get into that method, right? So, as you can see here, test A caught 3 real incidents, while test B has never failed once on anything. So now both of these test reports have the same exact test coverage. The coverage dashboard cannot tell them apart because it was never built, right? Okay, so let's define this properly. Because I'm going to use these 3 words for the rest of the talk, the question here is like which of our tests actually have a proven record of catching something real, like the production issues or something, right? Now the answer, the to replay basically the historical production incidents against every candidate test and measure what happens. How we're going to measure it, that's a different mechanism altogether. We'll come through that. The verdicts, like every test lands in one of the three buckets, as I discussed earlier: proven, duplicate, or unproven. That's the whole framework. Everything from here is what happens when you actually run it. So, though the answer is said in one sentence, we can replay every logged incident against every candidate test and give each one a verdict. So, what happens basically here? A test that fails on a real incident score is proven because it doesn't matter what its coverage percentage is or how many assertions it has. Ultimately, a test that has never failed on anything real scores unproven for this exact identical reason. And a test that only ever repeats a catch, something upstream, already made the score as duplicate, as we must have faced in our regular automation engineering or maybe quality engineering. So now, concretely, about 4,200 tests, as I said, we ran it over like 18 months, log production issues. So every test replayed against every incident, not just the one it happens to be written for, basically. So the cross replay is what makes this basically as an actual evaluation instead of a retrospective kind of pat on the back. Like we are seeing a candidate automation test, then the log production incidents, and every test is mapped 1:1 and cross-checked. Then we have the precedent state pulled from the timestamp deployment history. So this is the method for the data and scope. Now, moving to the four steps or the key four steps here, we see first, the incident gets recorded in the database. So once the incident is recorded in the database, second, we revert the system to its state just before that incident's first symptom, first time when the issue happened, right? Then, third, we replay every candidate test against that reverted state. Last but not the least, we tally which ones failed, and that tally becomes the verdict. So, as we can see here, a verdict comes from how often the test would have failed on something that actually happened. So, not how much code it touches or what it exactly does. So, that's the entire philosophical shift I'm asking you to make today. Uh, it's sort of a donut. So, so 80% failed on at least one incident, as you can see here. So no earlier test had already caught it. So we are also seeing 8% only ever get caught what was earlier flagged as an upstream issue, right? And then finally, the 12% never failed on a single logged incident across the whole 18 months. So let's slow down on each of these. We just saw the shape of that, right? Here's what each verdict actually means. So, what does proven means? Proven is nothing but the unique historical catch evidence. So, this group is doing the job. The coverage number always implied they were doing it already. So, now the duplicate. These are real signals, but always after an upstream test already flagged it. So that is not automatically waste, but these are already been flagged. What are the unproven? These are the healthy coverage where the zero historical catches exist and they have been flagged for owner review, not to be deleted on site. When you see it, you don't delete it. Now, coming to the duplicate versus unproven part. So, what does the duplicate do and the unproven? Though they look identical on a dashboard, they are not the same problem. So, what is duplicate? So, duplicate is redundant by design. Some of these tests fire earlier in a different stage on purpose, while as unproven just means that it doesn't have a track record yet. Okay. So, neither group gets auto deleted. Both go to the test owner for a conversation. Now, these are the limitations for reactive versus preventive test. So there is a honest limitation basically here, right? So when we look at it, it's structural basically. It's not an edge case. So what does a reactive test do? Once it catches an incident after it happens, that's exactly what this method is built to detect. So it scores correctly the proven method. So the preventive test blocks the bug or issue or whatever we are facing before it even becomes a loggable incident. So here we are looking at the prevention mechanism. Now, it can never accumulate cache history under this method by construction itself. So it scores unproven incorrectly, of course. Both tests can be equally valuable. Only one of them will ever look valuable to this score. Now, a small case sample example we have, like where we have a regression test for a playback stall fix, which never shows up anywhere in like 12 to 18 months of incident logs, not because it's worthless, but because it keeps falling, keeps failing in the CI, the continuous integration part on every attempted regression effort, right? So every time it tries to perform the continuous integration, it fails. So what happens here is even before the bug ever reaches production, we are seeing the issue, right? So under backward scoring, which is nothing but unproven, in actual value, the opposite of unproven is the like what we are doing here. Like the owner review caught that mismatches in just minutes, right? Whereas an automated cutoff based on the score alone would have definitely deleted it. Why will you go ahead and do that, right? Now, coming to the limitation for data quality, what we have here, right? So, there is another second limitation what we are talking about here. The incident that was never ever logged cannot be caught, right? Because by definition, no matter how good the test guarding against it actually is, a team with a thin incident history will see every test in their suit look unproven. So that's a statement about their logging discipline. So if they are not doing things properly, that they're not logging things, then we can't uh, justify that, right? It's not about their test alone, right? So what we do is we read every verdict this method produces as a floor on proven value, never as a ceiling of the total value. We are not talking about the ceiling, rather the floor, right? What we are dealing with as a proven value. Now, coming to the workflow, this is the key part as you see here, right? So, what we actually do with a low score. Now, we have a low score. So, as you can see here, we have a flow diagram where we are assigning to the owner, review for prevention, retire or label, and then confirm verdict. So, the verdict we are seeing here basically gets computed for every test. The unproven ones, what happens to them? They get flagged. So that flag goes to the test owner, not to a delete script. So eventually, there are two outcomes from here. First is the confirmed dead weight, that we don't have anything, we have no catch history, no plausible preventive story, which in turn keeps one from getting retired. That or a confirmed preventive which shows that doing his job upstream of where the incident log even starts, that one get uh, relabeled. Basically you can see that gets relabeled. So the conversation that follows the flag matters more than the flag itself. So we are having a definite conversation, like we are assigning the owner, then the verdict it goes to the test owner, he's reviewing it, then owner checks out the preventive story, and then the owner decides the outcome, and then finally the retirement or the relabeled proven comes into picture, right? So this is how an unproven verdict goes to the test owner and not the delete script. This is the entire workflow. Okay, now since we discussed the workflow, right, let us ask this question. So, how should you actually evaluate the effectiveness of your test suite? Is it uh, like not by just how many tests exist, right? So we have coverage threshold which push you to write more tests. They don't push you to write tests that catch anything. So what we have here, backward scoring targets that second problem directly. As you can see here, we have primary objective with the coverage thresholds and backward scoring. So if the primary objective is quantity of tests written, the backward scoring, it focuses on outcome of the proven catches. If we have what moves the number, then the coverage thresholds are lines of code and the branches it touches, right? So, but the backward scoring looks at the real incident replay. So, this is how we differentiate from the coverage threshold to the backward scoring. Now, coming to impact on verdicts. So, if the verdict is like kind of static regardless of the value, but in backward scoring, we have three distinct evidence based verdicts, which we have already discussed, right? So, now moving ahead, what are the key takeaways you will think, right? So, there are five things worth taking back to your own test suite. One is the coverage percentage and incident prevention, which are different questions. So we need to answer them separately. So why we need to answer them separately? Because they one is talking about the coverage. So coverage is nothing but the number of test cases you create based on the requirements, and if the requirements are mapped correctly, then you get close to 100% or based on that accordingly. And the incident prevention is a different thing altogether, right? So you need to know how we could prevent the defect. It can go back to a lot of formulas like defect density and sort of your test effectiveness, which ultimately leads to incident prevention, right? So now coming to the backward scoring, which replaces real incidents against candidate test to answer the second one. So how does backward scoring replay real incident against the candidate test to answer? Okay, so what happens basically in backward scoring? So we are looking at the proven, unproven test, right? So we decide whether the test can be proven or not proven. So that helps the candidate to decide in our current issue what we are facing. So about a fifth of this 4,200 test, which we are discussing since some time, carried no unique historical catch evidence, as you can see. So what does it mean? So this unproven verdict can mean dead weight or a preventive test doing its job quietly, which we are not aware of, though it is doing its job, but it is not relevant to us. So we need to flag the unproven test for owner review. So don't delete on a verdict alone, rather, but I would say just ensure that it goes to the owner for reviewing. So before moving to the next slide, just recapping whatever we did, uh, we talked about proven tests, which are failures on at least one incident no earlier test had already caught. Now we also discussed about duplicate. So proven, duplicate, and unproven are the three things which we have emphasized throughout. So duplicate, what is a duplicate? It's nothing but a real signal which always after an upstream test already has flagged. So those are the duplicate tests because we know that those tests have been covered somewhere else, right? Now coming to the unproven, right? Unproven are nothing but something which has zero historical catches. Not exactly the same claim as useless, but just that it hasn't caught any defects so far, right? So to describe the method, basically, first we record the incident in the database, then revert to the state just before the first symptom, and then replay every candidate test against that state, and then tally the failures into a verdict. So the two limitations which we discussed basically was a preventive blind spot, which is nothing but a test that stops a bug before it is even logged. So if we catch a bug even before it is logged, that helps to ensure that the score is proven, right, under this method. So no matter how good it is structurally, not a edge case rather. So this preventive mechanism helps us ensure that we get a proven result. Now we also discussed about incident log. Honestly, like an unlogged incident can't be caught by definition. So this logs whatever we are talking about, they make everything look unproven. So every verdict in the floor on a proven value never carries a ceiling on the total value, which we just covered. So I would like to emphasize on key distinctions. I think these are the terms which you definitely would have come across in quality engineering, like mutation testing. What is basically mutation testing, right? We have something called like synthetic bugs, proactive or exhaustive. So these category, why I'm talking about mutation testing, because these are the testing mechanisms which introduces bug, or you can say finds, discovers bug. So we find synthetic bugs, we find proactive, exhaustive. These are kind of real incident, and on retrospective or complementary rather, not competing in itself. We also talked about test impact analysis a bit, where which kind of predicts which test to run for a given change. Like it's not that you have to run all the tests and you have limited time, so you know which tests are suitable for test impact analysis. So this asks which tests are worth having at all. So now a few other things I will talk about. It's not covered in the slide, but I just want to give some more understanding about it. This term you might be aware of. If not, I will talk about it, like chaos engineering, right? So what does a chaos engineering do? So it injects failures into a live system to test its resilience. So how the resilience is tested? So basically this test whether your existing suit would have caught those issues or the failures that already happened, right? That introduces that sort of chaos. So that engineering around it is chaos engineering. So basically what we achieve out of is a resilient system against unrelented pressure, or from the, you can say, from our user actions or from lot of data, whatever we want to introduce there. Now, coming to observability or monitoring, right? All of us must have used an observability tool at some part, like it could be a Dynatrace, it could be a Splunk, it could be New Relic, anything as such, right? Because what they do basically, they tell us about an incident which is happening right now. So that is in retrospective, right, of the critical path. We run through a critical path and run against history. We see that this incident, whatever happened at the API level or code level, that could have been caught at this level. So we do retrospective and we come up with a ticket to work on it and fix that issue, right? We trace it back to the exact source code where the issue occurred, right? So based on our observability monitoring, we find that issue, right, and get details about the incident. So the other part regarding the coverage gap versus the unproven test. So what does a coverage gap do? Coverage gap says basically there is no test exists, right, for what broke. So there was a test gap or something missing, right, initially. But it's different than an unproven test, because an unproven test says that the test exists and it runs, but it doesn't catch any bugs. So that is a fine, that there is a definite difference between a coverage gap and an unproven test. So just don't confuse between them. So a few things I will just cover. So after that, I can take up questions. So how do you map an incident to a test deterministically? If you have to map any incident to any test. So basically, if you look at mapping an incident, right? So we need to look at the components timestamp. And once we have the timestamp, we will look into the coverage of it and replay it against the prefix commits. So if there are any prefix commits, we'll look into that. Then what gap we will try to find out? We find the gaps in the deployment history. They get excluded, right? Not approximated. So basically, if we look at all these characteristics, then we can ensure that we are able to map an incident to any test deterministically. So also, what about the incidents, you might ask, which have no test at all, right? So that is a definite coverage gap if there are no test at all. And the different finding altogether. We just spoke about coverage and the unproven test, right? So that's basically coverage gap. So a different finding from an unproven test. So that is the distinction we just spoke about. And another thing I think you must have all faced, how do you handle flaky test? So if you are not able to reproduce the flaky test, then that becomes challenge. Like if you have to fix your locators, or only the reproducible counts are handled as catches, right? A single flaky flicker is excluded and not scored in this backward scoring model. So if it is a flaky test, you look at the root cause of it and fix that, and ensure that there was not a code related issue, rather it was something which you can be, which was changed at the UI level, or something like something trivial, right? So you look into that flaky part, and ensure it's excluded and rather not scored in this backwards scoring model. um, you might also say, similar to mutation testing, however, uh, we're talking about synthetic versus real incidents. So mutation testing is kind of proactive, and this goes into empirical value. Like we are looking at a mature suit which kind of probably wants both of it, right? Both worlds, right? So it is looking at mutation as well as empirical. So, and also, if there is any question regarding bias, yes, definitely the deliberate, there is a track record of it. So the real limitation, as I said, is the preventive black spot, or you can say blind spot, what we are having. But that can be handled. It's not deliberate as such. So there could be some hindsight bias, but we can look into that. So with that, I conclude my presentation, and please come across with questions, and I'm welcome to address to the best of my ability. Thank you.
Thank you so much, Pat, for such an insightful session. I'm sure our attendees learned a lot. I saw that Q&A was buzzing a lot. So without a further ado, let's move ahead to Q&A. Yes, so we have question by Paul Filio. For the test that didn't flag anything, were they discarded or adjusted for the possible viability? What do you think on this?
Okay, this is a good question. I think we covered that. So for the tests which were not like, which we didn't flag, right? So it's not that the tests we didn't flag that were discarded. Okay, they were adapted basically and adjusted. So we didn't look at the test cases which kind of, we are not ignoring the tests based on the flagging of them, but we are ensuring that the backward compatibility whatever we are doing. So the unlogged incident, what you are saying, right? It's not looking at a hidden value. So the logging discipline is sort of a prerequisite, right? As we saying. So we are not looking at the side effect of not running tests. So basically, yeah, to answer your question, they were not discarded.
Great. We can move. We can pick one, two more. Yes. So Bharat has asked, could an agent that makes human more effective to be considered successful, even if it completes fewer tasks autonomously?
So agent is to form, like you're talking about an agent, AI agent, I believe so. So
Yes.
if that is the
Yes.
case, yeah, if it is an AI agent, so uh, and your second part of the question is, makes human more effective, right? uh, it makes human effective if there is a human in the loop, right? Because how are you going to tackle hallucination? Because it will generate a lot of loads of data, right? When we are talking about large language model, right, it looks so you need to see where it has been grounded. Does has been grounded on the reality of the knowledge you have, like knowledge in the sense you have, or sense knowledge you have poured into the system here, right? If it is grounded, then definitely it will be successful, not only in your view but also in the view of the uh, outcome of the entire product, right? And even if it completes fewer tasks autonomously, there is a very fine line, what how many tasks we are asking, and what is the number of tasks which we are requiring. So if you are talking about AI agents, we can always spin up parallel agents and do stuff like that. So it's not like and if accuracy is the point, so it's a fine line between accuracy versus kind of, you would say, right, the load of test cases. But if you look at the accuracy, then definitely you can spin up multiple agents or run them in parallel and get accurate results. Then definitely the count issue which you're talking about, I think that should be tackled. But definitely human in the loop is needed for an oversight, because you are the subject matter expertise of it.
That's an interesting one. Let's take one last one. Uh, you advise flagging unproven tests for honor review instead of auto deleting them. At scale, how do you prevent this manual review process from becoming a bottleneck for the test owners?
Yeah. So owner review, as I said, right? It's definitely we have to, as I always advocate for having human in the loop. So how many of the test case we are talking about, right? Do we think that all our entire thing is unproven? No, right? So we have to look at the proven set and believe that we have done the preventive mechanism for backward scoring and at a good scale, right? So at a scale, say for example, we're talking about 4,200 test cases here, right? If there are 4,200 test cases and we are trying to find a blind spot around it, right? So what we are trying to achieve here? So we are trying to ensure that the incident is recorded in the database first. Okay, once the incident is recorded in the database, how we prevent the manual review process from getting a bottleneck? So we can prevent it from getting a bottleneck, as I said, by analyzing. So say for example there was a mistake made, right? And you learn from that mistake. So initially there will be a little bit of challenges for sure, of course, but once you learn from those and reuse that in the next one, definitely will become definitely will become less. And we are not talking about one individual, you are not the only one who is taking care of it. And definitely with the usage of AI, a lot of things can be tackled better once, as I said, talking about the previous question, once you ground it to the realities that this is what is the exact, you can say, as we in QA we talk about expected versus actual, you give it a baseline of a expected result, this is what I expect, so this based on that it can also help you with getting those tasks taken care of. And it will not hit a bottleneck. So scalability will not be hit once you start using AI or start using parallelism of it or start improving it. Say for example, you don't repeat the same mistakes and it get inbuilt, you can say it kind of improves its process more over preventive over time. So those proven, unproven, and duplicate gets handled properly.
Got it. Understood. I think that would be it. Thank you so much once again, Parth, and thanks everyone who has joined in. We have more sessions lined up. You can check the agenda. Keep learning and happy testing. Thank
Thank
you.
you.